Hey, welcome back to Global Environment. Last time we were together, we started to talk about energy return on investment and best first. And what I want to do now is apply our knowledge from looking at Joe the fish to try to explain the diversity of life using EROI. And you can do that. So let's think about it. You look out the window, you see all kinds of plants and animals. Why do you see that diversity? You can use EROI to explain it. So let's look at this graph here. And this graph here looks a little complicated, but I'm going to break it down for you. So on the y-axis we have energy here. It's actually energy and time. But you can think of this as EROI. Now down on the x-axis we have ranges. But what we're talking about are gradients. And a gradient is a change in environmental conditions over space usually. And give you an example, we've got a lot of light in parts of this room and then it's darker in other parts. We have a gradient all the way through. We have a gradient in temperature. Some parts of this room might be warm and other parts cooler, and a gradient in between. So if we look at this graph, this can be any gradient we want, anything. Now we see energy being charted here for an organism. Now an organism has adaptations that makes it best suited for a set of gradients. So in this case, the organism is a happy camper at this center point. It has the most EROI, has the most energy left. So it can survive. It has enough energy that it can reproduce. Very happy right here. Now let's take a concrete example. We'll pretend this is a plant, and what we're going to do is say the gradient is moisture. So when we start going in this direction, what happens to the plant? Let's think about it. What happens to the plant? It starts drying up. Its tissues start to become damaged. It's expending energy to heal those tissues. It might use energy to grow more roots and look for more water. And if we look at the graph, because of these energy commitments, it might not be able to reproduce. It might get so bad it can't survive. All right? So this is all related to energy. Now, if we think about going in the other direction, now we're back at the graph and we start dumping tons of water on this plant, tons and tons of water. What happens? Again, tissue damage from the water. It's expending energy to heal its tissues. It might be expending energy to keep itself from suffocating, its roots from suffocating. Energy goes down. It can't reproduce. It can't survive. But if we go back to the center, this is where the organism is really happy. Now we're going to expand this. We just did it with one gradient. What I want to do is add more gradients, multiple gradients. So the next slide I'm going to show you is the slide we just saw, but I'm going to turn it towards you. I'm going to turn it towards you so you'll be looking like down on it, like on a map. Okay? So here it is. We're going to look down on it. And it looks a lot like this. Now, if you see, we've added more gradients. We've got gradient 1, 2, and 3. This could be anything. This could be sunlight, temperature, solar energy. It could be different aspects of disturbance. It could be, these gradients could be gradients of nutrients. Now, you get these isopleths here. And in the center is what you find is that is where the organism is the happiest. It has the most energy and most energy return on investment. Its adaptations match for that region. And as you go outside, things change. Okay. Now look at this map here. Let's see how an organism, its energy might change as it changes in its location in gradient space. So let's say this is a squirrel now. So we've got a squirrel, and the center is an oak tree full of nuts. So it's right on the bark there, right on the trunk, and then it goes off into the grass. There's still some acorns, but not as much as on the tree. Its energy drops if we look at this graph here. Then it gets a little closer. Maybe it climbs up the tree a little ways. There's some acorns available on some of the branches, more energy. Now it goes way out here. Maybe it's in the road or something. It's below the reproductive threshold. He's in the road. He's not thinking about the ladies. So, reproduction is right out. And then if we go back, it's right in the center of those isopleths. Great EROI. This organism's really happy. And it's interesting. Where have you learned about this point before? You learned about this in basic biology. What is this point? Can you think of it? It's the niche. You didn't learn about it this way, but the niche and the diversity of life, it's all about EROI. Okay, now I told you a great theory, great theory. It seems to make sense. Does it happen in real life? Well, if we look at this slide here, this is maize in Costa Rica, and it's graph versus temperature and precipitation. And the dark color means it's growing really well. This is a little less, this is hardly at all, and this is nothing. So what you're seeing here is the same behavior. You're seeing it in real life. You've seen why EROI is important. Okay, so we're going to stop here, and next time we're going to try to figure out if EROI and best first apply to humans. So see you next time.